You are listening to Ship It, a podcast about operations, infrastructure, and haunted codebases. I'm your host, Gerhard Lazu, and this week we are talking to Robin Morero, the person behind Fabled.se, a DevOps consultancy from Gothenburg, Sweden. Their motto is move faster and prosper, which I prefer to the initial move fast and break things. Fabled works with startups primarily, and after 26 years, Robin has a few interesting insights to share. What do you think? Are haunted codebases real? And at what point do pull requests become harmful? What about K3s running on KVM as a simple starting point for production? If this reminds you of episode 7 and the follow-up YouTube stream with Lars, it's no coincidence. Big thanks to our partners Fastly, LaunchDarkly, and Linode. Thank you for the great bandwidth, Fastly. You can learn more at fastly.com. Ship new features with confidence by getting your feature flags powered by launchdarkly.com. And thank you, Linode, for keeping our Kubernetes fast and simple. Run your setup as we do via linode.com/changelog.
What's up, shippers? This episode is brought to you by our friends at Shortcut. Have you ever really been happy with your project management tool? You know, they're so hard to get right. They really are so hard to get right. Most are too simple for a growing engineering team to manage all they need to do, and others are just too complex for anyone, and I mean anyone, to ever want to use them. They're just so painful. Shortcut, formerly known as Clubhouse, is different though because it's worse. Oh wait, it's better. It's better. Shortcut is project management built specifically for software teams, and they're fast, they're intuitive, flexible, powerful, and all the other positive adjectives you can apply to them. Let's look at some of the highlights. Team-based workflows. Individual teams can use Shortcut's default workflows, or you can customize them to match the way you work. Org-wide goals and roadmaps. The work in these workflows automatically get tied into larger company goals, and it takes one click to move from a roadmap to a team's work, to individual updates, and vice versa. Tight VCS integrations, whether you use GitHub, GitLab, or Bitbucket. Shortcut ties directly to them so you can update progress from the command line. Keyboard-friendly interface. The rest of Shortcut is just as keyboard-friendly with their power bar, allowing you to do virtually anything without touching your mouse. Throw that thing away. Iterations planning, set weekly priorities, and then let Shortcut run the schedule for you with accompanying burn down charts and other reporting. Give it a try today at shortcut.com/shipit. Again, that's shortcut.com/shipit.
We are going to ship in 3, 2, 1.
This is another real-world story of how others run ops and infra, what works, what could be improved. And the goal is to learn from a different perspective. And if we're lucky, maybe disagree on a few things. I love that. That's when I find myself learning the most. And we have Robin today that I hope will disagree with me on a few things. What do you think? Can we make that happen, Robin?
Hopefully we can make that happen.
Okay, so I would like to start with my favorite. I would like to understand what it looks like for you to take code from dev to prod. What is the path that the code takes for you from your development workstation to production?
Yeah, it depends on the context. But ideally, my dream scenario is to just push the code, make it land in production, and let it roll there. And check the observability. How does it behave in production?
Okay.
And then follow up and iterate. Yeah.
So do you have like a favorite project or a favorite code base that you work with? Because I'm interested in the specifics.
Yeah, we're working on facility management code base. That's one of them. What we do there is we try to provide a system for the facility owners to manage their facilities and their tenants in the facilities.
Okay.
So what we do is we code on it. We code backend, we code frontend. Backend is Go and frontend is React. And when we push that, it goes straight into production. It takes 15 seconds.
15 seconds, did you say?
15, yeah, most of the time. The front-end build takes a bit longer.
How long do your tests take to run?
Tests?
No, seriously. Are there tests?
Seriously, there are tests, but most of the tests are run after it hits production. We try to make it safe to deploy to production.
Okay. How do you know if you haven't broken something, if you push without running the tests first?
We try to make breaks as small as possible to start with, shipping small iterations. And also we try to run it in two separate environments. So with environments, I'm not talking about test to production, but just more like two different productions.
Okay. So do you mean like a blue-green sort of approach?
Blue-green canary type of deployment.
Canary. Okay, interesting.
And we mirror traffic between this. So traffic comes from the real production into the other one, but it doesn't really, if anything breaks there, it doesn't break the whole database.
So when you push an update into production, does it go into the live production or does it go into the standby and then you start shifting traffic from live to the new one?
Early on, it went straight into production, to the real production, while it was like a greenfield project. We were building it from scratch. But nowadays, it goes into the mirrored production environment.
Okay.
And we have some continuous traffic running there, and if the traffic looks all right, it's promoted to the real production.
So how do you know that the traffic that goes into the updated version looks all right? What determines that?
Metrics, observability and metrics.
Okay.
So instead of trying to build like test suites for everything, we build real simulated customers.
Okay.
So we build small bots that provide traffic into the system, and then we put when something happens, when something does break, we make sure to put a metric in there, a log line and a metric. And for the scenarios that we expect to happen, whatever could happen, we also do the same thing.
Okay.
It's basically similar to BDD, I think. Only it's less rigorous.
Yeah, it sounds like acceptance testing almost, right? Because you have, maybe actually acceptance testing is not the right word for it. It's more like end-to-end. I'm not sure how to call that test because you're simulating real users.
Yeah.
It is the behavior of the system, but I'm trying to visualize how you describe the tests or what are those bot users doing on the system that will inform you when something breaks.
Yeah, we're actually trying to simulate the use cases for the system.
Right.
That's, I think, quite similar to the first definition of business-driven design, I think.
Right. Okay.
So you write the use cases, you try to set up tests for these use cases. Only we don't do it as unit tests. We do it as live traffic into the production environment.
Okay. So you simulate live traffic, which obviously isn't live, like it's like artificial traffic.
Yes.
Do you go through like a set of steps or like, I'm trying to figure out, first of all, how many of those acceptance tests you have or use cases you test, and when do you start, when do you stop?
At the moment, we're still extending those. So it's not a lot of them. We got maybe like 20 suites or so.
Okay.
And they cover more than one thing because you see like user logs in, user does something. So it has similar, like several steps it covers.
I see.
And it goes all the way through down to the database, but it's a separate database from the production one. So it goes through the first service routes it to the next service with a header. This is mirror traffic. It should go to the mirror flow. So we use traffic mirroring a lot. So service meshes has been good.
Service meshes. Okay. So that's interesting. Is your production Kubernetes?
Yeah, it is. Or K3S, but same thing.
Interesting. So K3S. And are you running it like on a single node, multiple nodes? Do you have like a K3S cluster? What does that look like?
We got a K3S cluster. So we got maybe like 6 nodes or something at the moment. It's a pretty small system and it's not being used a lot at the moment.
Okay. In terms of database, what do you use?
We use Postgres. So we use a Postgres cluster.
Okay.
We use the Zalando operator.
Interesting. We used to use that. Did you have any issues with it?
And not really issues, but I would like to have a fully horizontal scaling version.
See.
Like we're looking at Yogabyte and we're looking at Cockroach.
Interesting.
So we're waiting for the GIST and the GIN indexes to appear in Yogabyte at the moment. What are you running?
Single node Postgres. Really interesting because we went with the Crunchy operator first.
Yeah, all right.
And we had issues with the replication. So we ran a primary and a secondary, which is like the standard one. And the secondary would fall behind. Then the write-ahead log on the primary would fill up the disk. Then that would crash. But the secondary could not be promoted because it was behind. So then we had no database. We thought that, right? We thought that Crunchy, there was like something weird happening with Crunchy. Like the whole configuration felt a bit more complex because apparently this thing is really complex, right? To get right the replication for PostgreSQL. We switched to Zalando and the same thing happened. And I suspect that a lot of this was networking related. So when there's like a networking glitch, sometimes the secondary just stops syncing, the write ahead log stops syncing. And when that happens, exactly the same way, the primary filled up, it crashed, it couldn't restart because the disk was full, the persistent volume was full, the secondary could not be promoted, so we had no database.
I think I've actually seen that with the Zalando one as well.
Yeah. So for us right now, we have a single PostgreSQL, which is continuously being backed up to S3.
Yeah.
And if you were to delete it, one of the first things which it does, it will download the last backup from S3 and it will restore from backup.
Yeah, that's nice.
So if we delete our database, it will just restore from the last backup. And then, so the backups currently, they run every hour. So at most we can have like an hour worth of data loss.
Yeah.
I would love to be able to set up like streamed replication to S3 so that we can, restore from literally like the last transaction, the last entry in the write ahead log that was synchronized. That would be better. However, having said that, I think having a managed PostgreSQL would really, really help so that we don't have to worry about this. And I'm thinking right now to go for the Fly managed PostgreSQL.
Yeah, that looks nice. Yeah.
And the idea there is that we could run multiple instances of the app and just connect to the same PostgreSQL instance. Currently, we have a single instance of the app. For various reasons, I won't go into them. But actually, episode 40, which came out just before this one, we talked about that at length. So coming back to your app and coming back to PostgreSQL, your use of PostgreSQL, you're using the Zalando operator, you have replication set up, the primary, secondary one.
Yeah.
Okay. Did you ever have to restore or like fail over? And how did that work?
It happens. And we kind of want to do that every now and then as well to make sure that we don't lose anything along the way. So we're trying to go for a portable and immutable setup. So it's disposable. We just throw it down and throw it up again. Make sure it works.
Okay.
And that's, I guess, one of the issues I have with the Zalando operator. I would rather have the horizontal so that I can just throw up new versions and it just,
Yeah, that makes sense. What about database migrations? How do you run them?
We run them as code. We put them in code and we make the small microservice that takes care of it. It does something in SQL and some things in code to just migrate it.
Okay. So when you migrate production, did you ever have a migration not work?
Yeah, it happens, but nothing bad so far. It was triggers that didn't work as well.
Mm-hmm. Okay.
That we were hoping, but we have a solution for it now, but it did break. Yeah.
Okay.
And those are the steps I guess we do a lot of test cases around. Trying to recover data, and so instead of we can't do that with fake customers all the way.
Yeah. So when it comes to your setup, what do you like about it?
I like how it's lightweight. Mm-hmm. I think as we go along and the further we get into the Kubernetes ecosystem, we're seeing I would almost call it the death of DevOps, but that's a bit challenging, I think.
Okay. Why do you say that? That's very interesting. Why do you say that?
I mean, what we used to have, I've been working in this industry for a while, right? We used to have this really big projects, and we had ops divisions, we had dev divisions.
Mm-hmm.
With DevOps, what I really liked about it was that you take care of your own code from design it, writing, deploying it, and checking afterwards. Mm-hmm. But as it grows more complex, you either have to keep more stuff in your head, mm-hmm. or you have to specialize harder. So you can't do both front end, back end, and ops. So that's the patterns I'm seeing. And what I'm seeing here is that junior developers or mid-level mm-hmm. have problems with doing real DevOps on Kubernetes. Because when something goes wrong, they can't read the logs real well. They can't see what happens in Kubernetes. So you end up destroying the feedback loop, I think.
Okay.
Meanwhile, I love Kubernetes, but it's basically new ops at this stage and not DevOps.
Yeah.
This episode is brought to you by our friends at Raygun. Time is of the essence when identifying and resolving issues in your software, and our friends at Raygun are here to help once again. Their brand new alerting feature is now available for crash reporting and real user monitoring to make sure you're quickly notified of errors, crashes, and front-end performance issues that matter most to you and your business. Here's how it works. Set thresholds for your alerts based on an increase in error count, a spike in load time, or new issues introduced in the latest deployment, along with custom filters that give you even greater control. You can assign multiple users to make sure the right team members are notified with links directly to the issue in Raygun. This takes you to the root cause so much faster. Never miss another mission critical issue in your software again. Try Raygun Alerting today and create a world-class issue resolution workflow that gives you and your customers peace of mind. Visit raygun.com to learn more. They have usage-based plans that start at $4 a month with unlimited apps and users. Again, that's raygun.com and start your free 14-day trial.
I think many call it a platform for building platforms.
Yep.
And using Kubernetes directly is almost like an anti-pattern. You shouldn't, as a developer, do that. And the expectation is that there's like some higher level primitives built on top of that. For example, you mentioned logs.
Yep.
Logs will be all aggregated in a place. And it doesn't matter which Kubernetes cluster things run in. All the logs are centralized. Same thing for metrics.
Yep.
Same thing for traces. Same thing for everything else. The point being, as a developer, I mean, okay, Kubernetes is there and maybe you're aware of it, but you still just git push and then everything else comes together and you know where to look.
And those are all nice parts, right? But what happens when something goes wrong? Because it still happens. For instance, like a Unity developer do something wrong in the code and their application keeps restarting and they don't understand why.
Okay, so when they look at the logs, can't they see why their application is restarting?
I see a lot of people having trouble understanding that. It takes a while for them to understand that pattern.
Okay.
I mean, they can learn. Everyone can learn. But at the moment, what I'm seeing is that Unity developers have problems with it.
Okay, interesting. So you see younger developers struggling with, okay, and I say younger, maybe less experienced developers.
Yeah, it doesn't have to be younger. It's like people with lack of experience in the cloud development field, I think.
Okay. What is the operational model that they are used to? Are they used to SSHing into servers? Like, what would make it easier for them?
I mean, it varies. If they come from the Ruby ecosystem, they had one way of doing it. It was a lot of SSH and a lot of running the, I don't know, that's Ruby deployment tool. I can't remember what that's called. You probably know.
Capistrano?
Capistrano, yes.
Okay.
So they used Capistrano. And then you got PHP on one side, you got Java on one side. Each of these crowds have their own way of doing things. So it's not like one unified way. It's different, I think.
Right. What about a platform such as Heroku? Is that something that they are used to and familiar with?
Some of them are, and some of them really like it. And I mean, Heroku is by default simpler than Kubernetes when you look at it to get started with and follow up. But it's the same thing. It's a platform. So, yeah.
Do you see all these tools adding complexity and maybe a lot of it is not needed? Is that what you see?
I think so. I think a lot of our work as developers is to manage complexity when we should instead be reducing complexity.
Right.
I mean, we set up frameworks for managing complexity and we are fascinated by them and we try to improve that. But there's not a lot of talking about reducing complexity.
So do you think that if we didn't have Kubernetes, things would be less complex?
No, I don't think so. I think Kubernetes fills a role, but I really liked it at the beginning when it was simpler. You still had to know it, you still had to understand how it worked, but as the ecosystem grows, you have expectations that you need all of these parts in your Kubernetes ecosystem and you need to learn the new tools.
Okay.
So I think this situation is similar to what happened in the JavaScript world when you went from like old school web development to framework development. You have a lot of new tools and a lot of new libraries that you have to learn to get on with your work. Yeah.
So what would you say is complex in the world of Kubernetes? What became complex over time?
The growing ecosystem is the big part, and the constantly changing ecosystem. Which parts are you using Kubernetes? Are you using persistent volume claims? Are you using things like where do you put your logs? How do you route your traffic? Are you using a service mesh? Which ingress are you using? I mean, it depends and it varies. If you have seen one environment, you haven't seen them all.
Yeah, so like the diversity in the different Kubernetes configurations, which obviously doesn't mean just Kubernetes, it's all the stuff that runs on top of it. And they're like slight variations, so it's difficult to know where to find the logs, where to find the metrics, where to see the events, stuff like that. Okay.
And then you could add to that, I mean, that's part of it. When you use it on your own and you host Kubernetes, so you run on a self-hosted one, that's one thing. Mm-hmm. But if you add to that something like AWS or GCP, then you have to understand that environment as well. You have to know where to look for things. You have to know how to set up and configure things.
Okay.
The developers might not have to like set up, but they have to know where to find their logs and how to read them.
So is there a list of tasks maybe that you've seen developers struggling with repeatedly? Like you keep mentioning logs. Is that something which they find difficult with Kubernetes?
I've seen a lot of developers struggling with trying to find the right logs.
The right logs, okay.
The logs they want. So trying to sort out from this log flow which logs am I interested in.
And how are they getting these logs? Like, do they go to Kubernetes directly, or do they use something else to look at those logs?
Most of the time it's something else, right? And it varies. I mean, depending on what to use, some tools are easier to use, some are harder.
Okay.
But if you take AWS, for instance, find the logs in there can be quite tricky depending on what you're looking for. Mm-hmm. And GCP as well. Datadog, I love the tool, but it's sometimes, if you have a lot of logs in there, it's hard to find the right ones.
Okay. Which is your favorite tool for looking and finding logs coming from Kubernetes workloads?
I like Datadog a lot for the power of it. But should I choose one for myself, I would go with Loki at the moment.
Loki, interesting. Okay.
Just because it's lightweight. I like lightweight stuff. Have you tried it?
Yeah, for sure. Grafana Cloud is one of the integrations that we have. So we run Grafana Agent in our Kubernetes, and that streams all the metrics and all the logs to Grafana Cloud. And then we use the hosted Loki, it's not Prometheus, it's the Grafana Cloud alternative to Prometheus.
Is it something like Cortex or?
Cortex,
no?
Thank you.
Cortex, yeah.
Cortex, that's exactly what it is, thank you. So they have like their own Cortex version. And Loki is inspired by that as well.
Yeah.
And there's Tempo as well for the traces, which we don't use. But we run 2 of each kind. So we use Grafana Cloud and Honeycomb. So we send our logs to both, and then we can pick and choose which one we want to use because we doubled it up. Have you tried Honeycomb for logs?
I've tried Honeycomb. I really liked it. But when I'm setting something up for customers, I want to have it portable so I can move the environments around.
Okay.
Because we're also seeing, I don't know if it's the same at your end, but we're seeing a lot of worry about GDPR and Schrems 2 at the moment.
Yeah, I know what you mean.
Where the data is stored. So depending on how that works out, they might want to move the data.
So for that, are you running your own Loki? Like you manage?
Yes.
Okay. Do you use Grafana as well, part of the metrics system?
We use the full Grafana stack, I guess. Grafana, Loki, not Tempo yet, same as you, but Cortex set the background as well.
And how do you deploy them in Kubernetes?
We deploy them with Helm at the moment.
And how are the developers finding the Loki interface? Do they struggle with it, like to find the logs that they're looking for? I think it's still an issue, right? Because otherwise you wouldn't have mentioned it.
It is. What we try to do there is to set up like dashboards and finished list of logs for their services. Mm-hmm. So each team has a dedicated dashboard where they can find the most common logs. They can find their dashboards for the services, how they're acting at the moment. Okay. And the same thing for a service to see service logs, service behavior. So we're trying to prepare it depending on tags, I guess.
I know that when we were talking, you were mentioning about this platform that you were thinking about. How does that link to what we just discussed?
Yeah, what we're doing is we're experimenting with setting up a platform. It might end up as a product one day, but it might not. At the moment, it's just like trying to find out, can we automate DevOps patterns better than they are today? Mm-hmm. So that we get like continuous reading of DevOps patterns, like how long does it take to deploy? How fast does it deploy with the production? How often does it fail and so on? Mm-hmm. So we're trying to build in these best practices into a platform and see where that leads us.
Okay.
And we're doing that for individual customers at the moment, but we're talking about doing a platform for it and pitching that. Yeah.
Okay. What would this platform look like in terms of like the big components? Obviously, there's going to be Kubernetes, but also a bunch of things on top of it. What are those things? Yeah,
we're looking at what we shouldn't have, really, more than what we should have. We're trying to get rid of complexity first to make it as small and light as possible and then build up from there. So we're looking for base, we're looking at K3S instead of Kubernetes because it's more lightweight. And in terms of logging, we're looking at the Loki Grafana. Instead of going with something like Elasticsearch that consumes a lot of resources and is harder to maintain, in my experience. Mm-hmm. And Nuts for events. Nuts yet streamed the new version. Really like that one. It's amazing. Yeah. And in terms of database, we're evaluating Yugabyte at the moment, which is like a Postgres wire compatible, but horizontally scalable.
Interesting. And would you run all those services on the same Kubernetes cluster?
They would run on the same cluster, but for different customers. So we do like, instead of multi-tenancy, we try to do like a single tenancy for each customer in this case.
Yeah, so each customer gets its own cluster or their own cluster, and that cluster has these components pre-installed. Okay.
Different namespaces, but same cluster. It could end up in different clusters, but at the moment we have it in the same one.
Different namespaces, but the same cluster. Is that what you said?
Yeah, exactly.
So one customer would have one cluster, but different namespaces for their different teams?
Yeah, I mean, no, sorry. No, the infrastructure would deployed in a separate namespace from what they're working on in terms of their own services. I guess that's kind of standard, right?
I see. Okay, yeah, I understand now. Okay, I get it now. And how would they provision, for example, new Yugabyte instances or like a Loki? Would they share a single Loki instance across everyone?
Well, the customers we work with are mostly small customers, startups, scale-ups, and so on. So they don't really have all of this enterprise needs. So they would start with having just one instance of the database. And if that later becomes an issue, then we have to fix that.
I understand. Okay.
But at the moment, we don't have any of those customers that need more than that, really. So it's mostly one team customers.
Okay, so those customers don't have like these components pre-installed. What about the ingress or external DNS or things like that?
Yeah, we have to set that up in each cluster as well. We're using Traffic for that.
Traffic, okay.
Yeah, and for external DNS, we're probably using, we haven't decided that yet, so I'm not sure what I should say about that. But
okay.
We're discussing and leveraging the Cloudflare APIs.
Interesting.
Yeah, but we're not sure yet, so any input there would be interesting.
We do use external DNS ourselves to manage all the DNS records. Until today, we've been running it on the Kubernetes, which is like the current production, whenever we need to deploy a new version of production, which typically happens every year, so that when we don't do upgrades in place, we just set a brand new one with like the new version, that we migrate things one by one, do the service updates. If there's any issues with like any of the new versions, we can always go back. So I think it's very similar to your two productions, as you mentioned.
Yeah, exactly.
And external DNS, in our case, it just talks to DN Simple, which is our DNS provider. It's fairly simple. That's all there is to it. We use Ingress Nginx and Cert Manager, but I can see how maybe if we could just like use just Traffic, which would manage certificates for us, maybe we will do that. So it's a consideration for sure.
Yeah.
And how will the updates, the code updates for the customers make it into production? What is the mechanism via which those updates go out?
That hasn't been written yet, but what we're looking at is something similar to what we do today. They push their code to a Git repo. We listen to the Git repo, we throw it to Tecton, and Tecton builds it and deploys it. So we create pipelines for building and deploying code.
And Tecton, does it run in the same cluster?
It runs in the same cluster, but in that other namespace. So in the platform namespace, I guess you could call it. Yeah.
Interesting. Okay. So you run the tests and the builds, maybe mostly like the dependencies and all, like building the artifacts inside the same Kubernetes with Tecton. And then do you push an image somewhere?
We push the image to Harbor.
To Harbor, okay. And that also runs in the same cluster?
Yeah, it does. I mean, we run it on specific nodes. We tag the nodes. We taint the nodes. So specific nodes handle specific types of platform heavy lifting. To not affect the customers as hard.
Interesting.
Yeah, so we're just trying to keep it simpler from terms of setup.
I would really like to see this setup, how it all comes together, all the components that you use. Is this something that you are thinking of maybe opening up to the public?
We're thinking about that, yes. We're doing a demo we're working on at the moment, something that will be like a public demo.
Okay.
And then what we're talking about is to release the CLI tool we're using as an open source tool to be used by anyone, but also to keep the platform like the web-based management GUI and so as part of our product.
Interesting. So what will the CLI tool do?
The CLI tool will create a cluster for you, depending on your provider. What we got integrated at the moment is like just Hetzner, but it could be like anything we write an interface for, really. Hetzner and K3D at the moment is what we're using.
With Hetzner, do you provide bare metal hosts?
No, we run it on KVM.
On KVM, okay.
So we create like virtual machines with KVM, and we run Kubernetes on those, or K3S on those machines through the cloud API. Yeah.
Right. So what does the CLI tool do in terms of Hetzner? What happens there?
The CLI tool creates a project for you. It creates your keys, like SSH keys, to be able to secure the cluster, and then it creates KVM machines for you. Logs into those and deploys K3S and all the dependencies of the platform.
And on Hetzner, so I'm still trying to understand that integration because you mentioned KVM. Do you talk to the Hetzner API to create anything? Like, what does that integration look like?
We tell Hetzner to create a new server for us. It should be this size, it should be this type, it should have the taints we don't really set there, but we have it in the configuration for that node. So we tell Hetzner to create a new node for us, a new server. And then we create a bunch of those and tell them to join the same cluster.
And that server, when it gets, so like those servers, when they get created, what operating system do they use?
Yeah, that's something we're looking at. But at the moment, we're using Ubuntu, standard one from Hetzner so far.
Okay.
We would like to have a ready snapshot, just deploy something lightweight, just show up, like to get it faster up. So we're talking about doing a node pool for that, like have always a couple of standby nodes that we just promote to use this now.
Ah, interesting. Okay, and on those servers, on those like physical bare metal machines, you create VMs using KVM. Is that right?
Yes, but that part is like Hetzner at the moment. Hetzner creates the KVM for us. What we're going for is that there's a lot of KVM hosts, right? You can pick any host basically, and they have KVM support. So we want to be able to integrate any host that you want in the end. If you have a host that you want to use in your country that's better compliant with your demands, we integrate with that one. And we get the same. The only thing they need to have is an API, but most of them do.
Okay, that's very interesting.
So we had to find one type of standard to deploy it to, and we chose KVM for now at least.
Wow, I would love to see that code. That sounds super interesting. I'm very curious now. Okay, yeah. Why did you choose K3S? That's a very interesting choice, especially for production, and I'll tell you why.
I love to hear why. Like I said, this is an experiment, and we're trying to keep it as lightweight as possible. We want to see how light this can get. What can we get by without having? And then we mightn't have to add parts, but what can we do with the bare minimum parts? So that's what we're trying to do.
So K3S, I like it, especially for experiments. It's a very lightweight Kubernetes, and I know it is compliant. Like if you run any of the compliance tests, it's like a certified Kubernetes. So it behaves exactly like the real deal. What I have found, especially on certain operating systems like Debian, when they switched the IP tables to like the newer version, there were issues with K3S not being able to set the IP table rules correctly, and it was leaking rules, which meant that as time went by, you end up having hundreds of thousands of IP table rules to the point that everything was slowed down to a crawl. So there were like issues like that, which goes to show that the integration between the operating system and K3S sometimes can be problematic. A better approach, again, in my experience, seems to have been operating systems that were built for Kubernetes, and that's like the entry point. You don't add Kubernetes on top of an operating system. The operating system is Kubernetes. And then when you provision the host, it's already mostly worker because the control plane nodes, they're managed. And that's, I suppose, where like the value of managed Kubernetes comes in, where you don't get to do anything when it comes to the control plane. That is the provider that does it for you. But I understand that from a GDPR perspective, and customers that need to control all of that, they need to know exactly where those are, what they are. And I'm not sure how like the GCP, for example, how do they do that? But I think because they have in Zurich, right, in Switzerland, it's one of the places where you can get like a managed Kubernetes from like a GKE from GCP. Would that not be an option for you to go for a provider?
Yeah, we have some customers that want all of their traffic and data in Sweden. And I mean, in terms of hosted in Sweden, there's not a lot to choose from. There are options, but they're not that strong at the moment.
I understand. Okay.
So even if we would pick a node in Sweden, the traffic would go through other countries on the way. So, I mean, as long as it's not a deal breaker for the customer, that might be a good option. But when it is, then we want to find a solution for them. And I wish I could disagree with you on K3S, but I do. I see where you come from, and you're totally right. And that's what we want to do. I want to have pre-provisioned Kubernetes-specific nodes that you start up in KVM. So not put it into the existing operating system, but instead provision an operating system that's prepared for it. Yes.
I have been looking at this briefly. I haven't spent too much time, but if I had to solve the problem that you're solving, I would most probably look at something like Talos OS, which is a operating system built specifically for Kubernetes. Everything is controlled via the API. It's immutable, and it was built from the ground up for that. So there's like a purpose-built OS with rollbacks, with everything that you would need to get a good OS experience for Kubernetes specifically.
Yeah, that's one of the posts we were looking at. Also Flatcar, I think, and K3OS.
Yes. Flatcar, that's another one. That's like the core OS, right?
Yeah, I think so.
Yeah, when that was like shut down, terminated after the IBM acquisition. I know that was like deprecated at some point. There was a fork, and Flatcar was the follow-up. I haven't used Flatcar, I have to say. I've heard of it, but I haven't used it.
But yeah, we're going that direction. We just have to find something that works. That's the thing.
Okay. Another operating system that I was really impressed by recently was NixOS. This is very recent. I really love the declarative nature, and I realized that a lot is possible with it, which you don't even need Kubernetes for. And it's still early days. I'm still experimenting. I'm running my first production instance. I converted to the Nix package manager for one of my Macs. Actually, that's this week's episode, and that will give away when we are recording this. That's the one which hasn't come out yet. But I really like some of the principles behind it, I have to say.
I keep hearing that people like it. I haven't tried it a lot. I've read on it, but yeah.
I think it would be worth experimenting with. Now, would you run Kubernetes on it? I don't know. But I like the declarative nature in that everything is configured via a config file or a series of config files.
Yeah.
And everything is kept up to date by this built-in auto deployer, which keeps pulling down the config and it keeps applying it continuously. So you have a systemd timer, which does that over and over again. That is a very interesting idea, I have to say.
Yeah.
And you have rollbacks and a bunch of things so built in. It is mutable. It's not an immutable OS in that you can't even write to partitions, which is something that Talos OS does, because you're not meant to do that. I mean, it just, it restricts you because everything, you consume it via the Kubernetes API. That's how you're supposed to deploy your stuff on it, not on the operating system directly. No,
and that's good, I think. I think that's a good approach for it. Yeah. So we're basically trying to keep it portable at this stage. We just want to build it, we want to test it, see how it works, and then we iterate.
What's up, friends? This episode is brought to you by Rewatch. Rewatch gives product and engineering teams async superpowers, and it helps them move faster with greater clarity. And I love clarity. Imagine this, all of your team's videos all in one place. Record, organize, and share the videos that your team needs to ship great work. Keep everyone in the loop by sharing team meetings, from sprint planning to daily stand-ups to project retros. Empower new hires to get up to speed faster with onboarding and training videos that are easy to watch, and of course, Rewatch. You can streamline knowledge sharing by creating a library of product demos, tech talks, architecture reviews, and so much more. And we're using Rewatch here at Changelog, and the killer feature for us is every video is automatically transcribed and searchable. And the transcripts are surprisingly very accurate, which makes it so easy for us to search key phrases, terms, and find and play the exact spot in a video. Plus, there's commenting and threaded conversation options on every single video. Now, we have a home for all our videos to enable our growing and distributed team to participate in any conversation asynchronously and on their own time. Check them out. Get started for free with a 14-day trial at rewatch.com. Again, rewatch.com. And by our friends at Sentry. Build better software faster, diagnose, fix, and optimize the performance of your code. Over 1 million developers and 68,000 organizations already use Sentry. That number includes us. Here's the absolute easiest way to try Sentry right now. You don't have to do anything. Just go to try.sentry-demo.com. That is an open sandbox with data that refreshes every time you refresh or every 10 minutes, something like that. But long story short, that's the easiest way to try Sentry right now. No installation, no whatsoever. That dashboard is the exact dashboard we see every time we log into Sentry. And of course, our listeners get a deal. They get the team plan for free for 3 months. All you gotta do is go to sentry.io and use the code changelog when you sign up. Again, sentry.io. and use the code changelog.
As a consultancy that sees many small businesses, many different teams, you get to experience a lot of different code bases, a lot of different approaches. Some are better, some are worse. They all can be improved in different ways. But you mentioned something which I found really interesting. You mentioned about those haunted code bases. What did you mean by that?
That's a term we use sometimes for a code base that the developers end up being so scared of making changes to it because they never know what will happen to it. It might end up with having to fix tests for a week. It might end up with bad bugs reaching production in a totally different area from what you're fixing. So they end up with this fear of making changes to the entire code base. And we used to work with the customer like that. And they were running a really big test suite to make sure that it didn't crash anything. And this test suite was taking like 40 minutes to run. So it was a slow feedback curve, and it ended up flickering about like 50 to 70% of the time.
Okay, so any change going into production would have taken maybe an hour, maybe longer, right? Based on this test suite. Interesting. Okay. And how did the team that was responsible for that code base behave?
It was a shared code base. The test suite was shared between different teams. So there was this huge discussion with like 5 teams or something, how we should approach this. And some of us wanted to cut the test-specific parts, but there was a general feeling of fear. We didn't want to do that because we might end up being haunted by it.
And what happened afterwards, after this discussion? What did you do?
We tried to make it smaller in parts, but we couldn't really agree on how small we could make it. So I suggested putting metrics in there, measuring what value do we get from each part of the test. If this test suite fails, what cost would it have made for the business? And how often does it happen? So the same thing that we do all the time, like if you can't prove something, measure it and check the metrics.
Okay. That is really powerful, the scientific method, of course.
But I was still met with some resistance because there was this like haunted feeling over it. They were afraid to do something. Everyone was afraid to do something with this code base.
So did you end up putting those metrics in?
We put some metrics in there and we managed to make it a bit better at least. We fixed the flickering.
Okay.
But it went really slow. And we did a little by little to make it happen. And we ended up not reaching the goal before I left, at least. So in second, afterwards, I wish we could have done it faster. We could have made more metrics in place directly and prove or disprove the value of the test.
Okay. So do you think that if you had placed those metrics quicker, you would have gotten to a better place to determine what to remove, what to keep?
I think so. And I think we shouldn't have been so afraid of just making changes to the test suite. Because if you're keeping that afraid of something, I mean, if you see it not catching a lot of issues, I saw it, and during my entire tenure at that company, I saw it catch, I think, 3 bugs. And if you just calculate the cost of this, not just the running cost, the waiting costs, but there's also the maintenance cost of that test suite. And also the delay in making any changes to the actual code base. It ended up being really expensive.
Do you think that multiple teams sharing that test suite or those test suites was part of the problem, in that you had many people had to agree on what to happen, and as a result that agreement never happened because there was always someone thinking something else?
Yes, I think so. I think that affects psychological safety as well, because if you're afraid that the other team will blame you for doing it, you probably end up not doing it. But I've seen the same pattern in smaller companies as well. When you start building up this feeling of fear when you want to make a change to the code base. And it's not just fear, it could be just like resistance. You don't want to make this change before you go home today, because you might end up having to wait half an hour for test suite to complete.
Interesting. So do you think that if you had removed the entire test suite, that would have been acceptable? Like, would people have agreed to that? Let's just remove everything and let's start over.
I mean, it's risky, and people would not have approved of that directly, and I wouldn't have either, but I would have liked to cut it into parts and remove the most obvious parts first.
Okay. How long did it take you to be part of this until you had to leave? Was it months, years? How long did it take?
Oh, it was at least 1.5 years. I think 2 years, something like that.
Okay.
It was an ongoing discussion. It wasn't all we discussed. There was a lot of other issues as well, moving to Kubernetes and so on. But there was an ongoing discussion about this test suite that never really landed.
Anywhere. Okay, interesting. So now with that experience, what would you recommend to teams that are still building out the test suite? So they don't have something which is quite as bad, but they have a test suite which is getting worse. What would you recommend?
I keep hearing talk about how you should have test suites for everything and you want to have 100% coverage and so on. I don't believe in that personally. Like everything, I think tests should be prioritized compared to everything else you're doing in your platform or in your product. It could be security for one thing. Do you want to completely forget about security because we're writing tests at the moment? So I think what I'm saying is that make sure that you capture the value when you're writing the tests. And if you can, put the value in there. Put a log that says that this test just failed. It would have costed this much if it had actually done it in production.
So I think that the tests that you're thinking about, they must be acceptance tests. They can't be unit tests. They can't be something that runs really, really fast. They must be expensive tests by design. Okay.
These were integration tests between like 20 microservices or something like that. And the communication was causing flickers as well, and the data state between the services. So a very complex test.
Interesting. So do you think that those were microservices, or was it more like of a distributed monolith?
Both. It was a distributed monolith combined with microservices. So it was in the process.
Because a microservice, by definition, it's self-contained and it exposes like a public API that, there's like a contract for that. And that's what you really care about. As long as you don't break the API, or at least there's like a way to version that, then things should be fine. And the teams, they shouldn't really share, I don't think, a test suite which tests all the microservices, because then they're not microservices, they're something else.
Yeah, that was part of the point I made, that I wanted to like separate them and test the contracts between the services.
I see.
So that's how I wanted to separate it. But in the end, there was a lot of data being affected. This was like processing data from one step to the other. And all of these microservices parts handled the data on the way. So they were afraid. There was a general feeling of fear that the data would end up being different if we made any changes in this entire chain. Like I said, it was haunted.
Yeah, I see what you mean.
Yeah.
But again, like that data is part of the contract, right? So as long as you implement the correct structures and there must be specification for the data, then everything is fine. And obviously you should do transformations between microservices. One thing which happens a lot is that the microservices don't do those transformations. And as a result, you're actually sharing the same specification or like the same data structure. And it's like an implicit one, so you don't make it explicit. And then you're afraid of changing it because you don't know which microservice may break. Because first of all, you don't know what data you'll be receiving. You're making assumptions, and everyone makes those assumptions because you don't have those like edges at the system. Interesting. Okay.
And also this was an old system. So some of these services were like, one was writing to the database, the next one was reading from the database. It was not a clear contract between all of these services.
I see. Okay.
And of course that can be improved, but then we ended up with a fear again. Making any change to it was so fear-laden that it never happened.
Would you choose a microservice architecture?
I'm a fan of microservices. The real one, not the distributed monolith.
So what does a good microservices architecture look like to you?
I think of it like minimizing risk. You can deploy one part of it separately from the rest. That's the big part for me. And then I want to have a clear contract between them. I want to have a clear responsibility. What is this service responsible for doing? And I want to be able to like quickly replace the service as well, to make it make it prototypable. We create a new prototype service that might or might not work better, but we're able to throw it away when we want.
So how would you capture those contracts between microservices? What would that look like?
I've been experimenting with that a lot, and we've done protobufs to set the version of the contract as a defined state. We've also been doing REST and trying to keep it like this version of the REST protocol is the contract between this version of the service and the next one. Because you might end up wanting to like promote one version of a service, right? You've got a transformation service, you want to be able to run version 1 and version 2 in parallel. So then you need to be able to handle both the contracts for version 1 and version 2. So I think there's a gap there. I think that would be nice to have some kind of standard for this. I haven't seen one. I'm not sure if you have.
No, I am still on the monolith bandwagon.
All right.
I mean, as weird as that sounds, I mean, Kubernetes is great. And I think many good things came out of it. But I think all this microservices craze, they're a lot more complex than people think. And there are like some hard problems, like the one that you've just mentioned. And I haven't spent enough time in that space to know what the solutions look like. But I'm not seeing problems with monoliths, especially when you have something like the Erlang VM, which scales really, really nicely. And you can have multiple applications running inside of that Erlang VM. So it's not just one application. And you have supervision trees. So I come from that world where I used to do quite a bit of Ruby. And then for a few years, I was in Go. And then for many, many years, I stuck with Erlang, including Elixir and Phoenix. And I see a lot of benefits to that approach.
But would you really call an Erlang application a monolith? I would probably call it like an orchestration layer or something like that.
You do have services within or you can have services within an application, but it's all about message passing. And because you pass those messages, you're a lot more aware about the contracts. So you don't call functions, you just send messages to, whoever is interested, whoever the subscribers are, whoever the processes
exactly.
are. So it's a lot more implicit, front of the mind for people. And like, for example, a hot code reloading, very few do that, which is how you would migrate from one version to another, right? When you change how the message is passed. Typically, you have a database where you write PostgreSQL, where you write data. And then when a new version comes up, you run a migration. And then the old version may break, but like, for example, changelog, we never had that happen.
Yeah.
Okay, it's not like the most complex app, but never was an issue.
I think you're pretty blessed there, working with the Erlang and Elixir. It's a bit different. If you work with a big Java application, it will behave a bit different from what you're seeing, I think. And that's my background. I come from a world where I worked a lot with big, massive Java applications. And you end up, I think, microservices, I don't see it as much as a technical solution to problems, but rather as an organizational one. How do you organize around your code base and how do you work with it?
Do you know who else thinks like that?
Santa Claus, maybe? I don't know.
Dave Farley, he wrote a book recently, Modern Software Engineering. I finished reading it. And that is one of the things which he says in that book.
I think it's a common, from people that have been doing microservices for a while, I think that's pretty common.
Yeah.
Because that's what we're after. We're not after like the technical solution. It's not the technical silver bullet. It's expensive, but you want the organizational parts. So it's tied into Agile, I think, in the end of it. Doing Agile right and microservices is a good combo.
Interesting. Yeah, I do have to say, if you're using Java as an org and you want to do something else, maybe you should consider Erlang and Elixir specifically, rather than going like Go, because that has its own complexities. But again, I'm biased because that's what I've been doing for many, many years, and I had success with it and it seems to work.
It depends on your setup, right? Because we're doing microservices, and with microservices, Go is a pretty nice match.
Yeah.
Because you end up with one static binary, and it's nice to package, it's nice to DevOps.
Yeah.
If I was doing Erlang Elixir, how do you manage that with Kubernetes for one thing? Is that straightforward?
It is, because we just build container images.
All right.
So there's a container image. It updates like any other thing. There's a deployment for it, which manages like the different versions. When there's an update, it picks up the update. We're using keyless-H. We are in the process of replacing that with something else. But as soon as there is an update to the image, it pulls the new image down. It starts a new version. The previous one is still running. If the new one, for whatever reason, fails, then it reverts back, like it rolls back. Actually, it doesn't even take down like the previous one. Part of like the new app booting, it does its migrations, for example. We never had a migration not work in 5 years now, so it was not an issue. Now, I do have to say it's a small team, so we're not like, 50, 100 people developing on it. But I think there's a lot to be said about, monoliths that work in even like big teams and monorepositories.
What I could see happening in a bigger team, if you work like that, I'm not saying this is the case. You have to tell me if you've seen it. But what would happen when you have like at least 50 people working on that code base and you have it in the same monorepo? Wouldn't that be pretty big? Wouldn't that be resource consuming if someone made an error somewhere that ate up a lot of memory and so on?
Apparently Google does it successfully. And Google, they have like one of the biggest monorepositories in the world. GitHub does the same thing. They have a monorepo for like all of GitHub. A lot of it still runs Rails, which is a framework. I don't know others like Facebook. I think they also have a monorepository. I don't know how they've made it work at that scale. There's a couple of conversations which I had like with ex-Google employees and ex-Googlers as they're called. And they have great things to say about how they approach this. So apparently they had it figured out, but they're a massive org.
Yeah, I keep hearing that they have separate tools for it to manage this monorepo because it's so big.
Yes, that's right.
But how would you do they still don't deploy that as one service, right?
Correct. Yes, correct.
So how would you do that? Like if you have a big Erlang application that grows over time, that becomes massive, how would you handle that in Kubernetes? It would be like one deployment still?
I would love to speak to someone that had that problem because I haven't. I mean, I would love to have that experience firsthand, like secondhand experience, I suppose, from someone that did it like firsthand. But I don't know.
All right. What do you probably good at the first where you wanted to hot swap code or something like that, maybe?
I think that is a very complicated problem. So you need to write migrations between versions because you expect the previous version to be in place hot swapped with a new one, and it needs to know how to do the transformations like function calls and stuff like that. Now, Kubernetes is not optimized for that because the expectation is there will be a new version starting up. You won't do an in-place upgrade. So it's expecting containers, it's expecting like a SHA, which changes between deploys. And with this hot code reloading, you wouldn't have any of that. You'd have like a long running thing which can automatically update itself. And that is at odds on how Kubernetes likes to do things.
I see your approach. And I think for small companies and so, I think a monolith isn't necessarily evil. It's just when you grow bigger and if you want to scale with it. I like the risk minimizing that microservices bring. It's not necessarily less work. It's not necessarily a silver bullet, but it minimizes risk when you deploy something.
One thing that I would consider as an alternative to that, I would consider a function as a service approach. The microservices are the functions. You can have multiple versions. And I would consider using a system like Knative, for example, to handle that complexity for me. Or using Tekton, that was the build part of Knative. And there's very interesting tools that do, for example, eventing. And all those primitives are abstracted away. So you don't care which, for example, message broker you use. You just use the Knative eventing primitives. I think that's a very nice way of doing microservices as an adult, as a grown-up, rather than having like ad hoc approaches. I like that idea. And I think that's what I would recommend to scale an organization versus microservices.
Yeah, and that will be part of the experiment. Knative is something we want to try more.
I mean, I spent a couple of months on the team, on the Knative team, on the eventing side, and that was a very interesting experience. And there's some very interesting people in this space that I wouldn't mind, making a few introductions to.
Sure.
I think they would enjoy it as well to have that conversation. But I really do think that something like Knative is a better approach than microservices.
We kind of want to try it in the same platform. We want to have it part, like selectable, and then we can iterate it. We can try it and see how it works, and we can continue working with it.
That is a great idea.
Yeah.
As we prepare to wrap up, what would you say is the most important takeaway for our listeners?
I would just say that try to question things when you do them. Try to find the value in what you're doing. And if you have issues with that value, try to do something else. If you don't see that value. If you're doing something that you think might be wasteful, try a different approach and see where it leads you. Don't be afraid to try new paths.
Yeah, I like that.
That sounds really cliche, but yeah.
Questioning things, including tests, I suppose, if you do TDD properly, it's less of an issue. But if you have a test suite that you've inherited or that you're struggling with, well, maybe that wasn't grown in the TDD sense. Maybe you have too many types of tests that are complicated. And listening to that pain is important and responding to it appropriately, not letting it rule you, like not being afraid of shipping into production, because that's a terrible place to be in.
And I would love to hear takes on how to measure that pain to deploy something. Any ideas, that would be great.
I think we instinctively know when the work that we do is a lot more difficult than it needs to be.
Yeah.
So you want to learn from whatever you're doing, like, does this thing work? Isn't that like the first question that we have? And if you think, or if you're convinced that it works, well, where is the proof to back that up?
Exactly.
Are your users telling you that it works, or do you just think that it works? And assuming that you're wrong, that is a much better proposition, because that's how you learn.
Yeah.
Right? Like, I think I'm right, but let me find out what others think, because the more diverse opinions and the more real world opinions you get, the better it is.
And I mean, it works is something that's kind of grayscale, right? It can work for you, but it might not be the best way to do things.
Exactly.
So you want to still approve that over time.
Showing it to people, getting it out there, and then seeing what they think and building on top of it, right? Because once you get it out there, someone else may say, you know what, I have a better idea. How about this? Or have you thought about this? And then you build on top of each other, for sure.
Yeah, because a lot of the assumptions we're working with today are based on like 80s or 90s. How we did it back then. We try to throw those away, but still a lot of them are still there.
Okay, so challenging assumptions. And yeah, I like that. Which assumption have you challenged recently?
We talked about having code reviews and not having code reviews in our team.
Okay.
And I mean, code reviews are really popular with a lot of people, and it quickly becomes a heated discussion. But the issue I have there is, why do you do the code reviews? In terms of learning and sharing, that's excellent. That's perfect. That's a tool you want to use, right? Mm-hmm. But do you want to enforce a tool to always be used? Or do you want to use that tool when you need it? And that's the question we have been struggling with. I
read this really interesting article, which is on this very topic, about Ship Show Ask. It's on martinfowler.com. Rowan Wilsenach wrote it. I'll share this link in the show notes. And what he's saying is that Ship is commit straight into main and get it into prod. So not a pull request. Show is when you create a pull request, but you don't wait for anyone to approve it. You just have it there. So you capture the change as a pull request, maybe add some context and get it out there. So you merge it yourself. Ask is when you're not certain. Oh, and I forgot about show. Also, the code review may happen after the merge. So it's an option, but it doesn't have to happen. The ask is obviously when you have to wait for the feedback before you merge. And I think that's the pull request model that you're thinking about. And you're right. If we always have to ask, it's a very slow way of getting changes out.
And what I've been seeing is that from when we worked with code reviews last time, we didn't see a lot of value because it ended up someone not having really have the time to look at it. You have to change your focus. You have to understand what the code and the business case does, and then you have to look at it. You can't just like, oh, that's code. It looks good.
Interesting. So I suppose this is in the context of companies that don't have maybe outside contributions, right? It's not like a public repository, just like private.
Exactly. But also, if you look at some of the open source projects, look at the Kubernetes codebase for one thing, and look at the threads in there after a code review, how long a delay it causes for a feature to reach usability. I'm not saying it's bad because it might lead to really good discussion. It might lead to better solution. But there is a cost there. It's not free of charge.
Yeah, I do have to say I'm a big fan of pushing straight into main and finding out if it works or if it doesn't really quickly. Getting it out there into prod, seeing if it breaks anything. And by the way, if you have a resilient system, it should catch these failures.
Yeah, that's the thing, right? You want to make the system resilient instead. If it fails, it's your problem. You did it wrong. It should not break anything. It should just continue rolling.
Exactly. That's a really interesting idea. I like it.
But just look at Kubernetes. I was looking at the API a while ago, and there were issues in the API that had been lying around for four, maybe 5 years.
Wow, okay.
I guess that's in the infancy of the API, I guess. In Kubernetes, it has been around that long.
I think a project as big as Kubernetes, with so many people contributing to it and making changes, there's bound to be issues like this, right? Which
exactly.
They just slip through the cracks and they're too complicated, and people can't find easy solutions to them, so they just stall.
Meanwhile, like the discussion builds up. There's new people come in and new people have the same problem and nothing happens. So what will happen down the line, like 10 years from now? Will we still have a Kubernetes?
Interesting.
Or what will be instead of that?
Well, I hope that in 10 years we'll have another conversation, or hopefully even before that, to see how that plays out, because that is indeed very interesting what will happen. Okay, so is this new platform something that, the one that we talked about, something that will be coming in the next 6 months or the next 3 months?
It will be released as an early adopter version within at least 6 months.
Okay.
Probably within 3. We want to try it with some internal customers first to see what the reception is.
Interesting. Okay. Well, I would definitely like to be part of those early adopters to see what it looks like, kick some tires for sure. And I would very much like to share anything that you have around it, with our listeners. Maybe they will be interested too, to see how you're thinking, what you're thinking, even if it's just like a blog post or like a demo. I think that'll be interesting to see.
I think the way to see it is like an evolutionary experiment and see where that leads. If you like it and you can use it, then we'll help you. We'll get you started and we'll try to see if we can do something better with it. But if there's no interest, we'll probably just drop it.
Okay, interesting. Yeah, checking if it works. I like that.
Yeah.
That's the work. Okay. Well, Robin, it's been a pleasure talking to you. Thank you very much for making the time today. And I hope to talk to you again soon. Thank you.
Thank you.
Thank you for tuning into another episode of Ship It. This is just one of our podcasts for developers. Go to changelog.com/master for the rest. You can join us for free via changelog.com/community. The only cost is happiness credits if you choose to not interact with us. There are no imposters in our Slack. Everyone is welcome. Huge thanks to our partners Fastly, LaunchDarkly, and Linode. Thank you, Breakmaster Cylinder, for all our awesome beats. That's it for this week. See you next week. One last thing. If you are running Docker Compose or Docker Swarm in production and have questions for the person behind it, send them to Gerhard at changelog.com.